2 reviews, yeah.
Wait, I think I have an extra thing.
16 on which one?
The one that you're on.
Oh, I don't. Yeah, whatever. Did you find something for him? Do you have something? All right, cool. Nice, thanks. Oops, I opened up the answers instead of the. Is that alright if I just do it like with the answers up there? Or do you want it blank? That's fine.
Wait, that's not it.
You saw the other one then?
Oh, yes.
Okay, so the hardest thing for this one when I looked through it, I kind of got stuck on DVDT for a minute. But you've got a circular oil slick. It's got a certain amount of oil, and it's just like spreading out. So the volume of it isn't changing. So that was I don't know where you got stuck, but for me, I got a little stuck on that. So DVDT is 0. But let's work through. So I will give you, if I need you to use the formula on the test, I'll give you the formula. So for volume or surface area or whatever. So I got V equals pi r squared H. So I would take all the derivatives. So dV dt equals. I like to leave the pi out there, and then do your fig plus gif because you do have a variable times a variable, right? So the derivative of the first thing is 2r times dr dt, and then leave the second thing plus gif. So the derivative of h is dh dt, and then leave the r squared. And then if I start plugging in, so like I was saying, dV/dt is 0, which I don't think we've seen one like that before, so that was kind of new. But if you just think about like a circular oil slick that's got a certain amount of oil and it's spreading out, it's not evaporating, it's just like drifting off to the side, so the volume of it isn't changing. So 0 times, and then they told me the diameter is 20, so that's super tricky to know. Okay, the radius is half of that. dr dt, that's what I'm looking for, because I'm looking for the rate of the radius. Height. Okay, so I gotta do like a side quest for that one. So for the height, I know volume equals pi r squared h. I know the volume is 100. I know the radius is 10. So I can use this to find out what h is. So it'll be like 100 equals 100 pi times h. So if I divide both sides by 100 pi, I get that h equals 1 over pi. Is that part okay? Please stop me if I'm going too fast or skipping through anything you don't want me to skip through. Alright, then dh dt, so they tell me the height is decreasing at 0.01, so that's negative 0.01, and then r I know is 10. Does that setup make sense? Like you can see where I'm getting the numbers and what I'm plugging in where and why. So then it's algebra, right? That 1 over pi is kind of annoying, but it actually goes away. So 0 equals, if I distribute, that pi and the 1 over pi will go away, so you'll have 20 times dr dt. And then this is 100 times negative 0.01, which is negative 1, times this pi. So negative 1 pi. And then like n divide. Is that okay from there? Yeah. Okay. Is that right for 16? Those ones with like the side quest are definitely tougher. Because you get to where you have 2 things you don't know. In this one, for a hot second there, I had 3 things I didn't know. Because I didn't realize that was 0 right away. I knew I had the side quest for that, and then I knew this is what I was looking for. side quest, but it was tough to realize. Any other questions on 16? What else? What else? The one with red bullet?
I just don't know.
So let A and B be functions of time. So that means that we're doing like the dAdt and dBdt and things are changing with time. I can tell by my answers too, right? That there's like the dAdt and all that. The sum of A and B is constant. Okay, so the only thing I know is that A plus B equals some constants. And then I'm going to take the derivative. You guys got a question?
He was asking about the dV dt y at 0, but it was because the volume is not.
That makes sense. Okay. I'm not like mad. I'm not trying to like get mad for you or anything. I'm just making sure you're clear on like whatever you're. Okay. So I know that A plus B is a constant. That's like literally the only thing I have to go off right now. So that's my equation. Well, then if I want to know how they're changing with respect to time, that means I got to go down a level. So I'm going to take the derivative. So what's the derivative of A? dAdt. The derivative of B is dB dt. And I don't know the constant, but whatever it is, what's the derivative of any constant? It's 0. And then if you just subtract dB dt from both sides, it matches up with answer B. How's that? Any other questions on 15? All right, what's next? 2D untested. The displacement fellow? So the displacement is just. That's okay. But because you're not the only one. Displacement is going to be the position at the end minus or height, position or height, or minus the position at the start. So it's not distance traveled. Like this particle might, I ended up going back 12 inches. I might have gone forward 100 inches and then back 112. I don't know. I just know that at the start, at the end, I was 12 units less than I was at the beginning. So you just take the plug in, it's like S of end minus S of beginning. And then you solve that. Is that okay? I don't know, Zach, that was good. I just want to point something out, and like you can take this for what it works, because I get it. I know people don't like to ask questions. But Zach's asked a ton of questions, which I super appreciate. Has anyone at any point thought, oh my god, what a terrible question, what an idiot? Like, has anyone thought that about Zach? I can't imagine that's going on, right? So like please understand that no one's going to think that about you either if you ask a question. I get it. It's hard to ask questions, but I'm just trying to like point out. You don't, I don't think, judge other people for asking kind of questions in AP calculus.
Except Matthew has stupid questions. If you say I don't understand 2A, that's different.
But it like
If the numbers were
if he raised that and says, can you go over number 4? Are you gonna make fun of him for that? But that's a different ball.
I have a question on number 4.
Okay, totally fine. Like I'm just trying to point out. I know that Zach is not the only one that has questions. I wonder what would happen. Which one? 4?
Yep, why, more specifically, why isn't it 6 and 9? And it's just
Wait, what number?
B.
E.
Because it says like at what time? Like at 6, like it's -3, which means like it has an acceleration of 3.
No, it doesn't. It means -3. You're thinking like speed.
Isn't acceleration the third derivative? I'm a
Second derivative. So it'd be the derivative of that. But at 6, it's negative. So the acceleration here is -3, like you said. The acceleration at 2 is 0, right? Because it's the slope of that.
Oh, okay, I see.
Wait, were you like reading it or were you taking the slope?
How I was doing it was I thought that it was like if let's say we'll use 7 because it's not on there. Like the speed would be 4.5.
So right there. Let's go through this. This is good. What is the velocity of this particle right here? Negative 4.5. What's the speed of this particle right here? Positive 4.5. What's the acceleration of the particle right here? Yes, because it's the slope. Because I've got to go from velocity to acceleration. So I'm going down one level, which means take the derivative. And on a graph, the way you take derivatives is look at the slope. So this was, these are halves. So the slope at 2 is 0. The slope at 6 is negative 3 halves. And the slope at 9, that's actually like just positive 3. And so it's just which one is the biggest. The negative matters for acceleration.
Yeah, I thought like if you're accelerating negative, technically you are accelerating more. It's just that you're going backwards. So like you are going faster, you're just going backwards instead of forwards.
See, when you say the word fast, that's speed. Fast and speed mean the same thing. Just acceleration has a direction. So just like velocity, speed does. So if I'm accelerating, can't accelerate that way. But if I'm accelerating that way and you're accelerating that way, and that way's positive, and I'm accelerating more than you are. We might be accelerating the same amount, but acceleration does have a sign. Just kind of remember that. Speed does not. That's the only one that does. What else we got on this one? Yeah. You didn't get number 7. I'm kidding. I'm kidding. I'm kidding. What did I do? What did I do yesterday? No, no, no. You said if it says explain, do we have to explain it? You didn't say like go over 7. Now we're just like making fun of you more, aren't we? This is getting worse. Yeah, I'm sorry. Okay, so 7. 2 ways you can do. Is this the right one? So there's 2 ways you can do it. You can do the old school way, where we would say, okay, I can't plug in because now I'll get 0 over 0, and then you can factor. And I kind of like to do these both ways because it's a way to. If I get the same answer, then I'm like pretty confident it's right. And then those would cancel. Now you can plug in -2, and -2 plus 4 is 2. Or we learn that L'Hopital's rule. You plug in and you get 0, 0. Or if you get infinity over infinity, which is not true in this one, but it could come up later. You get either one of those, you're allowed to use L'Hopital's rule. So you write down LH, which stands for L'Hopital's rule somehow, or LHR, or LR, or something. And then you take the derivative of the top, so 2x plus 6. You take the derivative of the bottom. So you're not doing quotient rule, you're just literally taking derivative of top, derivative of bottom. And then you try to plug it in again. And so now if I plug in -2, I won't get 0 over 0 anymore. I'll get 2. So to me, if I can do it both ways, like L'Hopital's and like the old way that we learned, that's really nice because then I feel pretty comfortable. But if I get the same thing, I'm good. So, thank you for asking the question. What else?
13 on the other.
Go back to test 1.
I only got one more question.
Keep them coming, man. This is like how I would write it out. Is it cool if I just talk through? So, I know it's going to be the DXCT stuff because the ant is walking along and it talks about like moving up and moving down. Talks about to the right and of a rate. So was that okay? Just like realizing I should do the dx dt stuff. Okay. The derivative of x squared is 2x, and I took the derivative of an x, so multiply by dx dt. This piece here is your product rule. So that's f prime g, and then g prime f. And then the derivative of y squared is 2y. You took the derivative of y.
I don't understand how to do the derivative. I guess what I'm struggling with
Oh, yeah.
is I know it's so basic, but the moving right and left thing on the graph, I don't know why. I don't get that.
So like, did you get negative 21 over 8?
No, I didn't even know, like, I don't even know what to do with the 3 centimeters a second because, like,
Oh, gotcha. Okay.
I don't know what to do with the right. Like, what is that?
So just think about like a regular graph.
Right?
If I said you're going to the right, that's this way.
Yeah.
So is that positive or negative? That's positive. You know, that's negative.
And
That's
so that'd be positive.
positive. And that's negative. I don't know if you're overthinking it, but that's
I think so. So basically that meant it was just a positive 3. The right means it's gonna be positive.
yeah. So did you? So dx dt is positive 3. And then 2 and 3 are your x and y. Did you put negative 3 there? Or is that?
No,
Or you weren't sure?
I didn't even like. I just had took the derivative. Like I
Okay.
didn't even begin to plug things in because I didn't know what. If let's say it was left, would like you just make it a negative 3?
Yeah.
And if it said down, it would be a negative 3.
Well, then it'd be dy dt would be negative, and then if it was up, dy dt would be positive. Another thing to watch out for on this, I could give you like reaches like when x equals 2, and then make you do a side quest to find y. So then you'd have to plug in like x in those spots, and I'd set it up so you could like semi-reasonably easily solve for y, and then use that. That's not this one, but I'm just like thinking of other things that could come up. Does that help then? Or
Yeah.
okay. What else? What else? This one? Equation for the tangent line at x equals negative 3. So I've got some function, x equals negative 3, and the equation of the tangent line is 4x plus 7. So 7 is up here, so it's something like that. And that's the tangent line. And I don't know what the curve looks like, but I know the tangent line is this. So I don't know if it's above or below, but like that's an example of something. It could be something like this. But I know it's gonna like bump up against it right at that point. So f of 0 equals 7. Well, that means in the original equation, if I plug in 0, I'm gonna get 7. But this is the tangent line. So if I plug 0 into this is basically like what this is saying is if I plug 0 into the red, I'm gonna get 7. But I don't know that because I don't really know what the original curve looks like. This is saying if I plug negative 3 into the red, I'm going to get negative 5. I know I don't know what the original looks like, but that has to be true because don't the tangent line, the blue tangent line and the red curve, aren't they going to hit the same point? So like it has to brush up against it. So I know that if I plug negative 3 into the tangent line, I get negative 5. So if my tangent line has a value of negative 5 right there, the curve, whatever it is, must have a value of negative 5 there also. I think that's probably the trickiest part there. And then if this is the slope of the tangent line, that means the derivative at negative 3 equals 4, because this is just saying, like, that's what derivative is, right? So slope at x equals negative 3 is 4, is what this says. And then I can look up here and say, well, yeah, the slope is 4. Does that help? Are we, before I do that, are we good on this one? Later, are you good? Yeah. Okay. On 13 on this?
Yeah.
I just forgot which test it was on. Okay. could put up at a rate of negative 21 over 8. I can accept that. So the problem is it says like be sure to specify direction. So I'd really prefer down at a rate of 28. But if you put up at negative 1, it's not really technically wrong, so I couldn't mark it wrong. Fair enough? How are you? What else? What else? Yeah. This one? Alright, write equation for the tangent line. You know what? Can I open up like the regular? This word like being in the way. So I need a tangent line. So I've got y equals blank times x minus blank plus blank. I know x is 2. So that's going to go there. The graph of that I'm looking at is okay, so g of x. So what's going to go here is g of 2, g of x, or g of 2. So I'm asked to find the tangent line of the graph at g. So I want the y value of g. Well, g is ln of f of x. So I need to find ln of f of 2. Does that make sense what I'm doing there? So what is f of 2? I'll read over here. F of 2 is 3. So then g of 2 is ln of 3. So I'm going to put ln of 3 there. Number okay? You can see what I'm doing on left. And then over here, I need g prime of 2. So first I got to find g prime of x. So to give me this, I've got to use a little bit of chain rule here. So what's the outside function of big guy? Ln, and then the little guy is f of x, right? So the derivative of ln of something is 1 over the thing times the derivative of that thing. Does that make sense for the derivative? And I want to know what's going on at 2. So g prime of 2 is 1 over f of 2 times f prime of 2. Well, this is my f. That was not what I was looking for. So what's f of 2? 3. So this is 1 over 3. And then what's f prime of 2? Well, how do I find that? You find the slope of it, right? Because the derivative of a graph is its slope. So the slope, if I find like a corner, like there and there, it's going up 2 over 1. So that's going to be times 2. And then I would put 2/3. And that's fine. Yeah. I mean, we did tangent lines this season too, but yeah. Is that good? What else we got? You guys look at the review of the. I don't know if the one in the book is any good or hard or easy. That's fine.
I just think the other ones are like bigger.
I agree.
Yeah. Okay. I thought it was
I mean, they both could be true.
It's valid. My mom made a copy this morning. She likes it a lot more calendar.
I didn't notice it, and now I can.
Yeah, it
Not
definitely
notice
is.
it. It is.
Actually, I thought it was.
This is because I've been funny yesterday. What else? Yeah. 13 on the test 2. I got radius is increasing, so drdt is 5. I'm looking for dsdt because they're saying how fast is the surface area increasing. They're telling me the volume is 36 pi. And it looks like that's all I know. So since I want dsdt, I'm going to want to take the derivative of the surface area equation. So ds over dt. And then bring down your 2. So this will be 8 pi r times dr dt. And I'm going to go to plug in, and I think I'm going to get stuck. So 8 pi. I don't know r. dr dt is 5. So how can I find r? I need it. I can't do the problem. How about I just tell you? Okay. So if I look at the other equation, that's why they give you this one. So it's side quest time. So volume is 4/3 pi r cubed. And they told me the volume. So this is the volume, not the change in volume, because it's saying the volume is not like the volume's changing. So 36 pi equals 4/3 pi r cubed. And then I can use that to solve for r. So I would probably the pi's will cancel. I think I'd multiply both sides by 3/4 because those would cancel now. 3/4 of 36 is 27, and that equals r cubed, which tells me that r equals 3, and then I can throw 3 back in there, and then multiply that all out. So I would probably do like 8 times 5 is 40 times 3, so I get 125. Divide by 4/3, but like we don't divide fractions, you invert and multiply, so you end up multiplying by 3/4 anyways. Does that make sense? If you want it to be like, I guess this would work too, because we don't have the pi, so you could say, you could go, I'm going to multiply both sides by 3, and then what's that, 108 equals 4r cubed, and then divide by 4. So you could like do it in 2 steps too. What else? You want to just play football and I saw your hat?
Yeah, yeah. He said he likes to have those, so it makes me memorable. I remember things.
What college? Are you looking at playing football, coach?
I don't know yet. Maybe.
Huh, okay.
It's always good to keep the options open.
Yeah.
Still knows.
What else? I recorded, like we just been taking questions, and I recorded it, so I'll put it on there. You guys, I mean anybody, you might go back later and be like, I forgot how to do this, whatever. What else can I do? Somewhat for you. Not him.
I asked him quick too.
Yeah, definitely have to share. I actually hate questions. That's what I mean. Well, you got time, I'm here. That's tomorrow. You will not get calculated.